Hello, welcome to Adventures in Angular, the podcast where we keep you updated on all things Angular related. This show is produced by two companies, Top End Devs and Envoy. Top End Devs is where we create top end devs who get top end pay and recognition while working on interesting problems and making meaningful community contributions. And Envoy provides remote design and software development services on a task basis. So clients only pay after the tests are delivered and approved. In today's episode, we are going to talk about a subject that it's definitely interesting for most developers, not just Angular developers, but it's also a subject that seems very hard, at least at first. We're going to be talking about WebAssembly and more specifically, how you can write code in Rust and have that code running in your Angular application in the front end. And well, you already know me. I'm Lucas Paganini, your host in the podcast. But joining me in today's episode is a very special guest. Evgeniy is a freelancer in Angular and also Rust, and he has researched on that subject specifically. So he is our expert to talk about that today. Evgeniy, thank you for your time. Welcome.
Hello, thank you for having me today.
It's great having you. All right, so let's start with the definition of things, because I threw in some concepts that I imagine lots of folks are going to be at least familiar with the names, so WebAssembly and Rust, but the reality is that there might be developers listening to us that don't even know what that means, right? So maybe we can start with just a 1 minute quick definition of what is Rust and also what is WebAssembly.
WebAssembly is a set of instructions, a special format, binary format, and programmers can use languages like C#, C++, Rust, Go to compile from these languages to special WebAssembly format and then execute this code at native speeds in browser. So it might sound cool if you need to execute something that's very computationally expensive with a huge performance, and some applications actually might use this benefit of WebAssembly. For example, it might be video processing, video games, LLM, like large language models, cryptography, and things like that. And maybe it's really not for every web application, but the application that need to do things like that, they definitely need WebAssembly.
Okay, awesome. And then with regards to Rust itself, I imagine that most people are going to be familiar with what Rust is. But for the purposes of our episode, you can replace Rust with just any compiled language that you want to run code in the front end, because we will be talking about Rust, but WebAssembly itself is not just specific to Rust, right? You could be writing code in C#, for example, and then use WebAssembly to bridge the gap between our regular front-end code in JavaScript and the binary, or maybe not binary, but the compiled code that you have written initially in C# or something, right? So we'll be talking about Rust because that was your experience and the technology that you chose to use to create your code. But for the audience listening to this that might not be fully comfortable with Rust, if you are comfortable with some other compiled language and there's something in your front-end application that needs to be extremely performant and you can't just rely on JavaScript code to do it, you need something heavier, or maybe you want to rely on libraries that don't yet exist on JavaScript, but they might exist in other compiled languages, then you can write your code in those other compiled languages and compile and then package them in WebAssembly, and then you can import them in your front-end code.
Yeah, that's it. Historically, there is a lot of developers that work with Angular using C# backend. And I think for them, it will be especially beneficial to use C# as a source language, not Rust. But because, and well, it happened like I have more experience with Rust, I wrote an article about Rust.
Okay. Regarding WebAssembly itself, what are the things that, like in your definition, when would you go to WebAssembly, and when do you basically, when is it a right call to reach for WebAssembly? Because it's a tool, and like other tools, you need to know what is the best place to use it so that you don't overuse it. And also, what are the things that you cannot do with WebAssembly, so that we also know when we definitely should not reach to it?
Well, if you need some DOM manipulation, then you should not use WebAssembly. But it's definitely a small niche actually for applications that should use WebAssembly. And if you are developing a video game or something like large language model or some audio editing software, then performance of JavaScript will not be enough for you. And I mean, maybe 90% of, or maybe 95% of web applications don't need WebAssembly. And those 5% that need it, they are definitely needed. So yeah, it's a rare case, but when you need it, it's nice to use.
Okay, makes sense. And in your article, you even gave some more specific examples of when to use it that I think are really interesting for people to think about some real world applications to it. So you mentioned complicated calculations, cryptography, even large language models. Like if you want to really run your large language model on the device instead of just making a remote API call, you could technically do that by importing the instructions for the LLM as a WebAssembly module. Also, image and video editing, games, and so on. So I think those are, thinking about those examples maybe brings people closer to scenarios where they, in the past, were trying to reach for something and didn't know what. So that would be a good application for WebAssembly.
Yeah, and it has some downsides. Like biggest one is size of the compiled model. Sometimes it's a few megabytes, sometimes it's 50 megabytes. So some applications just cannot afford wait while 50 megabytes web model will be downloaded before starting interacting with users. So it's one of the downsides. Yeah, it should be mentioned.
Yep. Okay. That makes a ton of sense. All right. Now let's talk more specifically about Angular and WebAssembly, because generally speaking, well, first off, anything that we can do with regular native front-end code, we can also do in Angular. But generally, Angular has its very unique way of doing things. It's a very opinionated framework. So do we have any different ways of importing and executing WebAssembly code in the context of the Angular framework? Like, does the Angular framework recommends any best practices or even enforces a way for us to deal with WebAssembly? Or is the way that we deal with WebAssembly code in Angular just how it is done with native front-end code?
I mean, right now we are closer to the second option. Now we in our Angular applications, we can import WebAssembly models as they are imported in native JavaScript, in vanilla JavaScript, and maybe a little bit later, maybe on the next week, pull request that was merged will be released in next version of Angular, and then we can import WAS models directly from Angular code using just word import. And it has a benefit that it's much easier to do. So you don't need a few lines of code. No, you can you can import WAS model in easier way. But downside of it right now is it will be imported without types definitions. So it will be like any everywhere and unknown everywhere. So yeah, it's more safe and not so much complicated and more, well, it's more safe to use the approach that is described in my article right now. But with the time, browsers will improve implementations, and then you can use WAS models inside Angular with types without any additional tools, and it will be awesome.
Great. Another downside, just to make it clear for the audience, is that currently the PR that was merged, well, besides the fact that you would have to be on the latest version of Angular because it was merged on version 18, right? So it will probably actually be released in 18.1. So you would have to be on the latest version. And currently, I don't know if they plan on somehow making it work with Zone.js in the future, but right now it is clearly stated on that PR description that it will only work if your application is not relying on Zone.js, which I believe 99.99% of applications are unfortunately still relying on Zone.js because the experimental zoneless APIs for Angular were very recently introduced, and we have had no incentives to really use them on production applications. We have actually being disincentivized of using the experimental zoneless API because it is so experimental. So I think most applications in production won't be able to rely on that extra sugar that Angular added to make it easier to integrate with WebAssembly. But they can still integrate it in the regular way, just using regular front-end code.
Yeah, it's only because top-level await is not supported. Because of that, you need a zoneless application. Yeah, well, I know a couple of applications working in production in zoneless already, but it's not the majority, of course, just a few of them in the world, I think. But yeah, if you are going to add the WAS model to your application, it actually means that most of the time it means that you are creating a new application. And if you are creating a new application right now, I would recommend you go zoneless. And even if you don't use WebAssembly in that application, I recommend you go zoneless.
Oh, that's really interesting. I know that this is not the main topic of this episode, but I have not seen any application, at least a production application, zoneless yet. And I have also not talked to anyone that has had production applications zoneless. So if you don't mind us getting sidetracked a bit, what makes you recommend that? Because from what I understand, the Angular docs themselves are saying that this is very experimental and you should not rely on this technology yet. It's not stable. But are you confident that it is stable enough to use in production applications?
As always happens with experimental things, it depends. It depends on what third-party libraries you use, and some of them are not quite ready to be zoneless. But to my surprise, many Angular libraries actually behave quite well in zoneless applications, especially if they are written with on-push only strategy. And if your application is written using only on-push strategy, that will be trivial to switch to the zoneless application. And it takes just maybe a couple of days to migrate medium-sized application into zoneless. So it's not that scary, but some libraries might not work with zoneless.
Gotcha. That's interesting. So it's not just a matter of you wanting to use it and starting a project from scratch. You also have to think about if the libraries you want to rely on for your project will work for it, right? Because maybe you write your code in such a way that will be fine, but perhaps the libraries you want to import are not going to work.
Yeah, exactly. Right now it's a main pain point with zoneless in Angular.
Gotcha. Okay. That is very interesting to know. All right. Now, getting back to WebAssembly. How does the thread work with WebAssembly specifically? Because we have been taught that JavaScript runs in a single thread, and whenever you want to parallelize work without blocking the rendering, there are multiple different technologies different techniques you can use to do that. So, for example, one of the most powerful one being service workers, or just web workers in general, because that way you can have your code running in a separate thread. But how does WebAssembly specifically behave? If I import WebAssembly code and I execute a function from it, is it going to execute on the main thread, or is it automatically going to be executed in a separate thread?
The main thread. And if you don't want to kind of create lags during execution of heavy code, it's better to load it using service worker or web worker. Then it will work in a separate thread. And heavy computations will be executed without blocking your UI.
Great. So we can also import WebAssembly code in web workers.
Yeah.
Awesome. Gotcha. So basically, if we want to parallelize things in a different thread without blocking the main one, the approach is still web workers.
Yes.
And if you need something to run faster, not necessarily run in a different thread, but just run way faster, then you can go with WebAssembly. And then if you need both things, then you can just use WebAssembly inside a web worker.
Exactly.
Cool.
And one specification is if your task involves a lot of numbers crunching, then it is cool to use. It is good use of WebAssembly. If you are operating with strings, with text, then sometimes JavaScript might do it faster because overhead of calling WebAssembly is not null, and WebAssembly is awesome for task based on handling of numbers, calculating the numbers, like drawing, some things with audio, video, But strings text is a different thing, and it's sometimes maybe better to check if JavaScript is good enough for that before you start implementing it in Rust or C#.
Interesting. With regards to this overhead of WebAssembly, is it an overhead just on init or on all function calls?
It's all function calls. It's not huge, like it's not a few seconds. It's maybe 50 milliseconds. But I mean, if you're trying to save every millisecond, then some tasks should be done inside JavaScript, and some tasks should be done in WebAssembly. I mean, if you want to just create MD5 hash, there is no use for WebAssembly because JavaScript will do it faster. But if you need to create some video game where you can zoom in and zoom out, then JavaScript has no chance to do it faster than WebAssembly.
Makes sense. Now, we also spoke about the bundle size, right? Like sometimes you can have WebAssembly modules that are just way too large. With JavaScript, we have several techniques to reduce bundle sizes. With WebAssembly, do we also have similar techniques?
Yeah, there are. Well, I was working with Rust, and there's a great tool, WASM-Pack and WASM-Opt, that help with optimization of WASM model sizes. And in Rust itself, some compiler configurations might help with binary size. And yeah, general recommendation is use fewer generics, use fewer strings formatting, and well, you can find more of them by links in my article, because it's not the short things to explain.
Okay. And in your article, the link that we have to shrink WASM code size is specific to Rust WASM, right? So I was wondering, because when we compile something to WebAssembly, it kind of loses the reference of whether it was written in Rust or C# or whatever, because it's almost like, correct me if I'm wrong, please, you have a lot more experience with WebAssembly than I do. But my understanding of WebAssembly, at least conceptually, has always been similar to what Java does, in the sense that Java compiles to bytecode. I think that's the right term. And then this is what it uses to be platform agnostic, right? So that it can run in different operating systems. And I always understood that WebAssembly did something similar. So if I wrote the same code in C or in Rust, but compiled it in WebAssembly, I would not have any references to the original Rust or C code. Of course, they would be different in the final compiled result, just because C and Rust are going to compile the same function in different ways. But the WebAssembly code itself is almost like a universal language and not specific to Rust or C. So I was wondering if that specific tool for shrinking WASM code size that seems to be, at least from a quick glance, very specific to Rust code written in WebAssembly, I wonder if that package, that library, also works for shrinking WebAssembly code that was not originally written in Rust.
Exactly because of the reason you mentioned. After you get WebAssembly binary file, you cannot do anything. You cannot shrink its size. There are actually two steps. First is you are compiling from your language, like C# or Rust, into a special set of instructions. And after that, this code will be compiled into binary. And on the first step, you can kind of, if you are super expert, you can manually edit the code generated from, compiled from your Rust or C# code, and maybe optimize something. But for example, I'm not that good. And after you created the binary file, that's it, and you can do anything, as far as I know. So all the code size optimization tools, they are bound to compilers. For example, it's CLang or script or Rust itself. They optimize the size using knowledge about the language. So it's the task that compiler does. So it's bound to a language.
Gotcha. Okay. So if I understood correctly, that specific technique of reducing, of shrinking the WebAssembly size of your Rust code, this is not like you run a command on the generated WebAssembly. It's more like you run the command on the Rust code before it's turned into WebAssembly. Is that correct?
Yeah, you kind of, yeah, exactly. You give some instructions to the compiler. That's how it works.
Okay, that makes a ton of sense. All right, so Evgeniy, we've been able to package a ton of content in just 27 minutes. I wonder if there are any specific topics that I haven't brought up, but you feel are really interesting to bring up to the audience.
Well, maybe about the Rust itself. I mean, nowadays, if you write in TypeScript and you want to try Rust, I encourage you to do this, because if you write in TypeScript and you follow the immutability approach all the time, and you describe types everywhere, you never use any, and then you're almost ready to use Rust, actually, because it's quite close to Rust code, to be fair, and it will not take a lot of time to learn it if you are used to strict typing, to follow to use immutable data where it's possible. Then, as I said, it will be easy for you to start writing in Rust.
Great. And what with regards to the syntax itself? I mean, you're saying that it would be really easy. I assume that is because if you're written very strict TypeScript, then you're already used to not specifically the syntax of Rust. It may be very different from how we write code in TypeScript. But I think the concept, I think what you mean is the concept of always being very specific with your types. Is that it? Or do you also mean that the syntax of Rust is also pretty close to TypeScript?
No, syntax is not that close, but what I mentioned is kind of rules inside the language, the limitations. TypeScript brings some limitations with types, and they are to help us. And Rust does the same. It has some limitations. Maybe sometimes you will fight with borrow checker, but it exists to help you, not to damage your mental health. And because people who write in TypeScript are kind of used to such limitations, it will be easy for them to meet such limitations in Rust.
Gotcha. Makes sense. Makes sense. And what with regards to the syntax itself, do you believe, let's assume a somewhat experienced TypeScript developer, let's say at least a plain level TypeScript developer, his or her experiences have been mostly with web development, and now this person wants to learn Rust. How long, let's assume that this person is like fully focused on on that learning journey. They're not bouncing time between college and work. They just literally pause their life to focus on that. How much time do you believe it would take for this person, fictitiously, to go from zero to at least productive in Rust?
If you want to create, for example, API for your backend for your website, then in 6 weeks you will be productive, and in 8-10 weeks you will get your API ready. That's how it was with me and with a couple other guys I know. And it's easier when you get help from the community, and Rust has very nice community. They help a lot, and don't be afraid to ask on Reddit or Slack or Discord. People are very ready to help you.
Nice. That's very good to know. Okay. All right. So, Evgeniy, I don't think I have any other major questions, at least nothing that I can think of. So, if you don't have anything else you'd like to bring up, I think we can start wrapping up.
Yep. Let's wrap.
Okay. All right. Let's just do some quick promos. Let's start with you. Do you have anything particular you would like to promote? It doesn't even have to be related to Rust or WebAssembly.
No, but read my Medium blog. You will find some maybe interesting articles, not only about WASM and Rust, but about other topics in Angular, such as signals, change detection, and other things. And zoneless too.
Awesome. I have just sent a link to your article in the comment section. Not everyone will see that because you might be in a player that doesn't support comments. But if you're watching us from YouTube, then there's a comment section there. You should see the link. Otherwise, if you're just listening to us, then you can look up on Google as Powering Angular with Rust, and you will most likely see Evgeniy's article be the first result on Google. Okay. On my end, I'm just going to promote the two companies that produce the show. So there are many other podcasts produced by top end devs. There's even podcasts about Ruby, about I believe they reactivated a podcast about freelancing, also JavaScript Jabber as a more generalized web development podcast. So highly recommend checking that out if you're interested in other technologies besides Angular. There's definitely a show inside the top end devs universe of podcasts that is going to be what you're looking for. And also Envoy if you are a company or know someone that is looking for either outsourced professionals to complete a project or a staff augmentation just to extend your current team. Envoy offers design and software development work. And the most interesting piece is that instead of just paying by the hour, which is what most agencies offer, they have a much more client-friendly business model where the client only pays after the work is delivered and approved. And the costs are estimated upfront. So you don't have to worry about overtime or the quality not being what you expected because the costs are defined beforehand. And if you're not happy with the quality of the delivered work, you can just request changes until you approve it. And it only becomes billable after your approval. So it's a very interesting model. If you're interested in that, just check out unvoid.com, Envoy, to learn more and contact them. All right, so that's going to be it for me. Evgeniy, thank you so much for your time. At least to me personally, I think this was an extremely valuable episode. this WebAssembly is something that feels too hard, feels out of grasp for most front-end developers, but it doesn't have to be. And I'm glad that we were able to break down some of the myths regarding the complexity of doing it. So thank you very much for that. And feel free to come back anytime.
Yeah, thank you. It was very interesting. And good luck with next episodes. It'll be nice to listen to them.
Thank you. Thank you very much. All right, folks. Thank you for sticking up until the end, and I will see you in the next one.